Hello everyone, welcome back to Algebra 2 class. Today we are going to continue our conversation about the trigonometry function. Today we are still going to focus on angle, and this time we are going to talk about the angle measurements. So whenever you talk about the measurements, the very first thing you think about the angle probably is degree, because that's a unit we describe how wide or how small for the angle. Sometimes we can say it is a very big angle or obtuse angle, 130 degrees. Sometimes we can say it is a right angle, 90 degrees, things like that. We always use degree to measure it. But today we are going to introduce another way to measure the angle. Before that, let's talk about the height. As you probably many students, if you come from different countries, you know we might use different unit to describe the distance. For example, in China and other, a lot of countries actually use centimeter, meters to describe the distance. Here we use feet and inches. For example, if we talk about the height of Taylor, then her height here we say is 5'11", but in centimeter it is 180 centimeter. But no matter which unit we use, we're actually talking about the same height, right? The height of the same person. But since we use a different unit, the description and the number we see is quite different. And we can always convert from one to the other. That's, actually consistency of the different kind of measurement. We can convert from one the other. So even you come from different countries, once you see the height, we can still convert the one we actually use in the current system. Same as angle. So angle, as we know, as I mentioned before, we always use degree to measure the angle, and the unit is degree. For example, as you can see, this is an angle here formed by two rays, and we use protractor. The one you see is more like, the half circle here is protractor. So we use a protractor to measure how wide for the space between the two rays here, and for this angle is almost 30 degrees, right? So this is the one we already know how to measure the angle, and what does that mean? We'll hear the word 100 degree or 50 degree. However, today we are going to use a different way to measure the angle. So now let's check. How do we use a different thing to measure the angle? So today, when we talk about the different thing, we are actually not using any tools such as protractor or ruler or whatsoever. What we are going to use, we are going to think about the circle. As we know, when we talk about the circle, we always say the center of the circle and the radius of the circle. So what happened in this case is I'm going to use this, imagine this is a part of the string for this radius. I'm going to use this radius to go over, trace the circle. So what happened is, imagine this is a string. I'm going to use the same string to measure the circle. I'm going to go along with the circle. For example, this is actually 1r. Imagine this is a string. I'm going to just trace this one. If this string is soft, I can just go around, to trace the circle. So this is one part of the string. So what happened in another angle measurement is this 1r, how long the string of the, I wouldn't say string, the length of the radius covered, the space covered by the length of the radius is called 1 radian. And this space is called 1 radian. Okay, so this is actually, I use r. So no matter this, how big or how small for the circle is, as long as I use this radius, the distance of the radius to cover the whole space between this is how wide a 1 radius can cover, and the space between this one, how wide between this angle is called 1 radian. It is always the same. And so the next question will be, if I just keep covering, for example, you can even imagine you are using the finger. For example, sometimes we say, hey, wait, how wide for the table is? You don't have a ruler. Sometimes you just use your hand to measure how many hands you can cover for the distance, right? You can imagine this is the same thing. I use a radius to cover how many radius I can cover the whole circle. So this is what we say here. I can just keep repeating this behavior, this action too. I use another R. This is probably another R here to cover the space here. I can just keep doing. This is another 1 radian. So I can just keep doing the same thing. So some student might say, then how many radian we can cover the whole circle? Is that 5? Is that 6? Is that, how many can actually cover the whole circle? So this is actually coming to talk about another interesting here. Check. So when we talk about the whole circle R, the circle here, we know, if we just go through the circle, we're actually talking about the circumference, right? And we know the circumference, which is what we see to stand for the circle, which is 2 pi r. So what does that mean? That means the whole circle has 2 pi of r can cover the whole circle, which means the whole circle has one circle, has 2 pi radian. Is that very interesting to make the connection here? So before we just say, oh, this is always a circumference we mentioned before, and now we actually know this is 2 pi of r. You can imagine this is 2 pi of r here. So the whole circle has 2 pi radian. Again, imagine you use a string. For example, you use a soft string to measure how long for the r here, and then you just use the same string to go over the whole circle, and you will notice the finally is 2 pi radian. This is what happens. So one circle has 2 pi radian. Now we are going to come to the conclusion to make the connection between the radian and the degree. So as we mentioned, if one circle, the whole circle, has 2 pi radian, right? The whole circle has 2 pi radian. Then, as remember, the whole circle actually have 300 degree, right? The whole circle is always have 360 degree. That's what we defined the whole circle is. That means 360 degrees, same as the space, the whole space between this, the whole circle angles, is actually same as 2 pi radian. Sometimes we write a radian as a unit, sometimes we don't need to write it, but we still consider whenever we put in this way, we know this is radian. So 360 degree equals to 2 pi radian. That's actually what we conclude from the circle, from the degree to the radian. I just want to, readdress again, the reason we actually use a circle to describe it, that's how we connect from the degree to the radian. And the most important thing is, angles in radian. Angles in radian is coming from we use the distance of r to measure the angle. It's a different way to measure the angle, but this is how we connect, this is how we use a new tool to measure the angle. And again, this is not brand new. We can still convert from the degree to radian by using this idea. So the conclusion we can say is, how many radians are there in the full rotation? Full rotation meaning the whole circle, which is 2 pi radian equal to 360 degree. And remember, if I say the whole circle is 360 degrees, seems to 2 pi, then what about the half of circle? How many degrees for the half of circle, which is 180? It seems that we divide, it's look like we divided by 2 for both sides. So that means 180 degrees, same as pi radian. Please make sure you keep in mind for this relation, because this is the one we are going to keep using today to convert between degree and radian. And these practices will be showing in next video. Okay, so the basic introduction for angle in radian is it. That's all I want to share with you today about the angles in radian. And in the next video, we are going to do some practices to see how do I convert from degree to radian or radian to degree. Okay, so see you soon everyone in the next video.